Azure Queue Storage provides a simple queuing solution for handling large volumes of messages. Storage queues allows asynchronous communications between different applications. This allows to decouple components, build resilience, and also scale for bursts of traffic. In this video, let's dive into Azure Storage Queues and understand the different concepts around it. We will learn this by doing it from an ASP.NET Core application. Hello everyone, my name is Rahul and welcome back to this YouTube channel. If you're new here, I make videos on .NET, Cloud and DevOps. So if this is of interest, please don't forget to hit the subscribe button. Without much delay, let's dive straight into the code and learn about Azure Storage Queues. Let's create a brand new ASP.NET Web API application using the .NET CLI and specifying new and Web API, which will use the Web API template to create a .NET application. I have the application successfully created, so let's open this in an IDE. I will use Rider for this example. So let's specify Rider and specify dot to open the current project. I have the project opened up in Rider. So here we have the program.cs, the startup.cs, and also a default controller class. Let's go into the weather forecast controller, which has the default get method. Let's add a new post method that can be used to post weather data to our API. Now let's assume posting a weather data involves a lot of background work to be done before it can be added to our database. For this example, I would just be adding it to a queue and not actually save to a database, since the intent of this video is to learn about Azure Queue Storage. So let's go ahead and add the new post method. So let's first specify the HTTP post attribute to create a post method. So let's specify public, task, and specify post, because this is going to post data to this API. We can take in the weather forecast DTO and specify data. Since this is going to come from the body, let's specify the from body attribute. Now, if you're not sure about how this data is getting bound in the API, check out my model binding video, which will be linked here or in the description below. Now, once we receive the data at this endpoint, let's assume we need to trigger off a series of tasks, which are long-running processes. In these cases, it's ideal to push these messages into a queue and have them processed in the background, so that the calling application or the UI does not have to wait long. Once this is pushed into a queue, we can have a background process, an Azure function, or a web job pick up this and then work on that particular message. To push this to a queue, we need to first create a storage queue. Let's first understand a few concepts around Azure Queue Storage before we head off into the Azure portal to create one. The Azure Storage Queue is a service for storing large number of messages. You can also access the messages from anywhere using the HTTPS or HTTP calls. Now, there are certain restrictions on the message sizes, like it should be 64 kilobyte in size. An Azure Storage Queue lives under a storage account. Within a storage account, you can have multiple queues in here. So the images to download and the images to resize are multiple queues. Inside these queues, we can have multiple messages. So each of these messages represent different workloads. So this could be our weather data or different data that we need to process based on our application needs. If you look at the URL format, the queues have the storage name with the queue.co.net followed by the queue name itself to identify which queue it is. So in this example, since we have the storage account as my account, the URL is myaccount.queue.co.windows.net followed by images to download to actually represent this particular queue here. To represent the images to resize, the last part would just be images to resize. You can get these URLs from the Azure portal once we create a queue. Now, an Azure Storage account is what we'll have to create first, because that is what contains the queue. The Azure Storage account also supports other types like blobs, file shares, tables, etc. So let's see this in action. So let's head off to the Azure portal to start creating an Azure Storage account and then an Azure queue inside that. Once we have it, we will use this from our application that we just created. So let's go to the resource groups. I have a resource group delete, which I'll be deleting after this video. So let's click create to create a storage account. So let's search for storage account and select that. Click create to create a new storage account inside the portal. Here we can choose the subscription and the resource group that it has to be associated with. So let's choose delete in this case and give this storage account a name. Now there are some restrictions on the characters you can use on the storage account name. So you can see it must be 3 to 24 characters and can contain only lowercase letters and numbers. So let's name this as YouTube Video Demo. Let's choose a region. So you can choose a region that's closer to you. In this case, I'll choose Australia East. Choose a performance. In this case, I'll leave it as standard. If you look at the documentation here, you can learn about the standard and premium performance tiers. Let's also choose a redundancy level. Now there are different redundancy levels. If you want to learn about this, you can actually go to the Learn More tag, which will give you an idea on the different data redundancy concepts that is applicable with queues. What you are selecting with redundancy is how the copies of the data is being stored in case one of the storage accounts goes down. Now redundancy ensures that your storage account meets its availability and durability targets in the face of failures. So basically you can choose between locally redundant storage, which is LRS, or zone redundant storage. You can learn more about by reading this in this article here. Now if we go back, we can see we have multiple choices for this redundancy. You can also see it has a short description with each of these scenarios. In this case, I'll use locally redundant storage because this is just for demo purposes and it is also the lowest cost option. Whenever choosing the redundancy option, choose between the cost and the trade-off that you are making. So let's leave it at locally redundant and click Review and Create. Once this is looking all good, let's scroll down and click Create to create our storage account. The resource is successfully created, so let's go to this resource. We have the storage account details and you can see the overview details like we just created. So it's in Australia East. It has a subscription ID that's associated and the different other properties that we had selected. On the left side, if we scroll down, you can see a data storage option which gives you different options. For this video, what we are interested is in the queues section. So let's navigate to the queues and start creating a new queue inside here. To create a new queue, let's click this plus button. Let's name this as weather data because this is going to be weather data coming into this queue. Let's also add in a add so that it represents adding a weather data and click OK. We have the queue successfully created. So if we click, we can navigate into the queue and look at the messages that's inside this particular queue. Since we have all of this set up, let's navigate back to our source code and start using this queue from our ASP.NET application. Coming back to Rider, let's add a NuGet package to start using the Azure Queue Storage. Here, let's search for Azure Queues to get the NuGet package that we require. We will be using the Azure.Storage.Queues NuGet package to interact with the queue that we just created. So let's click this and make sure to select Add to this particular project. The NuGet package is successfully installed. So let's create a queue client to talk to this queue that we have just created. Let's specify where queue client is equal to new queue client. Now this is coming from the NuGet package that we just added, which is Azure.Storage.Queues. So let's select that and use the overloaded constructor to pass in the connection string and the queue name that this needs to connect to. So let's specify connection string as a variable and also the queue name. We will just define this in a moment. For testing purposes, let's define the connection string right here, which I'll be moving later in this video. So let's specify that and also the queue name. So let's specify queue name and pass in the name here. For the connection string, let's navigate back to the Azure portal. Let's navigate back to the storage account. And if you scroll down, you can see an access keys section where you can get the connection string. So let's copy this particular connection string. So let's say show keys and copy this value. Let's navigate back to Rider and paste this connection string here. Now we will be moving this out from here later in this video. For the queue name, let's navigate back again and under the queues, we can copy the queue name that we created, which is add weather data. So let's copy that and navigate back and paste this for the queue name. Now we have a connection to the queue client. So let's add in a message to this client. So let's use the queue client.sendMessage method. We have a send message and also an asynchronous version of that. Let's use the asynchronous version and then specify the message text. This needs to be a string value. So in this case, we'll have to convert the weather data object into a string representation. So we can use JSON serializer to do that. So let's specify var message is equal to and use the JSON serializer to convert this object into a serialized string. So let's just say JSON serializer.serialize and pass in the data. Now we have the message in the string format, which is the JSON format, and then just pass in this message to this method. Since this is an asynchronous method, let's call await and make sure to add the async to this post method as well. Now here we have created an instance of the queue client called serialize on the data and just used the send message async to send it to the queue. Let's see this in action. Let's put a breakpoint here and press F5 to run this application. The application is running successfully, so we have the Swagger endpoint which shows the two endpoints on the API. So let's choose the post and try it out and click execute to send this message to our endpoint. So let's say execute and this hits the breakpoint as expected. If we look at the data, we can see this is populated with the data that we have just sent from the endpoint. So let's click F5. This will continue the execution. If we navigate back into the Azure portal, we should be seeing a message inside our queue. So let's navigate to that. And here we have a new message that's dropped inside this queue. So if you look at the message text, we can see this has the date, the temperature, and the summary that we had passed from the Swagger UI. You can also see this has got assigned an ID and then the insertion time and the expiration time. Let's understand a bit more about these different attributes. The insertion time is the time when this message was inserted into the queue. The expiration time by default is 7 days. So you can see in this case I have inserted on 30th of September and this message expires on the 7th of October. Now this is by default setting to 7 days, and after which this message will disappear from this queue if nobody has consumed or worked on this particular message. This also has a dequeue count which we will come to later. Now, when we send a message, we can change this default and make this a different value. So let's go back to the code and see how we can do that. The send message method has different overloads. If you look at the next overload that we have, this one takes a visibility timeout and also a time to live. The time to live is the expiration time that we just saw. Let's test this. So let's pass in a null for the visibility timeout, which we will come back in a moment later, and specify time span from seconds to specify the expiration time. So let's pass in 10, which means this will expire in 10 seconds. So let's run this app again and see how this is working now. Let's change the summary. So let's say expires in 10 and click execute. Now this is successfully posted. So let's go back to our queue and refresh this. Here you can now see that this was posted on 9/30th and this is expiring in 4/35. So once that time is passed, this message will expire from this queue. So if we refresh again, that message is now gone. It only stays in that queue for 10 seconds. So depending on how long your message needs to be living in the queue, you can set this value while you're sending a message. The other time that we saw was the visibility timeout. Earlier, when we send a message, it immediately appeared into the queue. But what if you want the message to appear after a certain delay? Let's say you don't want the message to come immediately, but let's say after 10 seconds or maybe an hour. This might be different use cases depending on your application. So let's say in an order processing scenario, if an order is processed, you want to wait for an hour before it goes to the shipping department. So you could put a message with a visibility timeout of 1 hour and it will show up in the queue only after 1 hour. There are different use cases for this time to live property. So let's see how that works. So navigating back to Rider, instead of passing null in here, let's specify a value. So let's click this and specify time span dot from seconds and specify 10 again. Now, since we have given the visibility timeout to be 10 seconds, let's make sure the time to live is more than that. Otherwise, the message will never show up into the queue. And this is also kind of an error condition. So in this case, let's specify this to be 20 seconds. So the message will appear in the queue after 10 seconds and it will disappear after 20 seconds. That's the total time that we are specifying here. So let's run this to make sure this works as expected. The application is running. So let's update this text to be, say, visible in 10 and expires in 10 and click execute. The message is successfully posted. So let's go back to the queue and refresh, and this message has not appeared yet. This will appear after 10 seconds because that's the timeout that we have specified on it. Now you can see, since the 10 seconds has passed, we have the message inside here. In this case, this was created at 4:42:04 and it will expire at 4:42:24 because we had given 20 seconds as the expiry time. Once we refresh again, that message would have disappeared. So based on your application needs, you can use the visibility timeout and also the time to live on how long a message needs to be in a queue and when it should appear. If you set the expiration time to be a negative value, then it will never expire. So if we go back to the source code, let's stop this. Let's pass a null so that the message is immediately visible and specify a negative value inside here. So let's say -1. Let's modify this message and makes this as never expires. And click execute. The data is successfully posted. So let's navigate back to the queue and refresh this. Here we can see that this message was inserted at 4:44:16 and this expiration time is set to the default value. This means this message will never expire. One way of exploring the messages in the queue is to use the Azure portal. You can also use the Azure Storage Explorer, which is a standalone tool that you can use on your computer. Once you have downloaded this, you can open this from your computer. So I have it already installed. So let me open that and show you how you can see the same queue inside the Storage Explorer. Now there are different ways you can connect to the Storage Explorer. So if you click the connect button on the left sidebar, it gives you the different options. In this case, since I have a connection string, I will use that to connect. You can also add your Azure account so that all the storage queues and accounts is visible on this sidebar as well. So let's choose connection string for this example and select next. In this case, let's say the YouTube demo as the display name and paste in the connection string. So if I use the Windows and V key, I can use the clipboard manager and then select the connection string that I copied a while back. So let's paste that in here and click next. This gives you a summary so we can specify connect. We have successfully connected to the YouTube demo storage account. So if you expand that and under the queues, we can see the add weather data queue. If you have more queues, that will all list in here. So let's select the add weather data and you can see all the messages inside that here as well. So just like using the Azure portal, you can start interacting with messages from the Azure Storage Explorer. You can double click the message to see the details of this message as well. Now that we have seen how to successfully add a message and also see the messages in the queue, let's see how we can start consuming these messages from our application. Now there are different ways you can run these messages from your application. In this video, to keep things simple, I will use a background task. If you're new to background tasks in ASP.NET Core, I highly recommend checking out this video linked here or in the description below. The other ways you can process these messages is using an Azure function or maybe even a web job. I will walk through that in different videos later. So let's come back to our IDE and add a new background job. So let's open the Solution Explorer and create a new class for our background job. Let's add a new class and call this Weather Data Service. So this is the background job that we will be creating. Now to create a background service, we need to inherit it from the background service class. So let's do that. This has a few missing members, so let's make sure to implement them as well. This adds an execute async, which is the method that gets called when this background service runs. Now in this particular case, we need to keep polling on this particular queue as long as our application is running. So let's specify while and specify the stopping token dot is cancellation requested. So we need to run this as long as this is false. So let's make sure to add a negation at the start. So as long as this cancellation is not requested, which happens when the application shuts down, this while loop will keep running. Since we need to connect to the queue, we need the queue client here as well. So for now, let's simply go back there and copy this 3 lines so that we create a queue client. Once we have seen the background job, I'll show you how to refactor this out as well. So let's go back to the servers and make sure to paste this in here. Let's make sure to include the missing references and start using the queue client. For this example, let's simply log the messages from the queue and we'll not do any processing. But based on your application, you might have different processing needs on the data from a queue message. To log, let's first add a constructor and add in a iLogger interface. So let's specify iLogger and pass in the weather data service as the category. Let's specify logger and make sure there is a backing property for this particular field. Here, let's first write logger.log information reading from the queue. To start reading the message, let's specify var queue message, which is going to be the message that's coming from the queue. So let's specify the queue client dot read message async. Now this has 2 different methods, which is the read message and also the read messages. As you expect, the message returns one value and messages you can return multiple messages. So you can pass in a number of messages that you want to retrieve in a single read. For this example, let's simply use the read message async method. Now this is going to read the first message inside this particular queue. Since this is an asynchronous method, let's make sure to add the await call. And since I've added the await, we also need to make sure the execute async has an async before it. Once we have the queue message, we need to make sure it has a valid value. So let's specify queue message dot value is not equal to null. Now, once the messages has run out, this value is going to be null in the next read. So let's specify that and start processing this message. For this example, let's simply write this into the log statement. But if you want to convert this into a real data, you can also use that. So let's say where weather data is equal to, we can use the same JSON serializer dot deserialize, specify the weather data object, so in this specific case weather forecast, and pass in the string value. So let's say queue message dot value dot message text. Now this is going to be the value that we have written initially to the queue. We know that this is in the JSON format, hence we can deserialize it using the JSON serializer. Now if you're using a different format to write the message, you can use the similar way to read it back as well. Let's simply log this message. So let's say log information and specify new message read and pass in the data that we have read. So let's say weather data and pass weather data as well. Ideally, inside here, you would be doing your application process to process this message. For this example, let's skip that part. Now once a message is successfully read, we want to wait for a few seconds before we make the next poll. So in this case, we can say await task.delay and specify the time period to wait. So let's keep this to 10 seconds in this particular example. So let's specify timespan.from seconds and say 10 as the value. So every time this background service is going to be run, it's going to look at the queue client and then get the top message from the queue and log this out. After that, it waits for 10 seconds and then polls this particular queue again. To add this weather data service to our application, let's go into the startup.cs. Under the configure services method, let's call services.add hosted service and pass in the service name. In this case, this is weather data service. So this is going to run this background service on application startup. Let's run this and see if this is working as expected. Let's put a breakpoint here. And once the application has started up, this breakpoint is successfully hit because our background service is loaded and then it calls on to the queue. Now let's step through this function and see if our queue message has any value. In this particular case, we get back one of the messages which has the message text as summary string. This is the first message that we had dropped into the queue. Because of this case, this is the first one to come out. This follows the first in and first out principle. So we can deserialize this message into weather data. So if we look at weather data, we have all the valid data for that particular object and we are successfully logging this. Now after 10 seconds, this is going to read again. Now, if we go back to the queue and refresh it, we can see that the messages are not visible here anymore. This is because we have read this. But if we refresh this after a certain amount of time, this will reappear again. This is because in our application, we had only read the message, but we did not acknowledge that we have processed the message. Because of which, after the read, it waits for some time and then the message reappears in the queue. So if we refresh again, we can see the other message will also come back. You can see the dequeue count here has now increased from 0 to be 2. This is because this message has been read 2 times. Now, how do we completely remove this message once we have processed this message? So if we come back to our application, once you have successfully done your application process, we can mark the message as deleted. So let's specify a wait. Let's call in the queue client and pass delete message async method. This takes in 2 properties. One is the message ID and also a pop receipt that comes with the message. So let's call the queue message dot value dot message ID. This is the message ID, and we can also pass in the queue message dot value dot pop receipt. Now this is also a property on the queue message. So once this is deleted, this message will be gone forever. So let's run this to make sure this is working as expected. Let's also put a breakpoint here. The application is running, so here we have the breakpoint. So this is going to delete this particular message. So if we look at the weather data, we can see this is the message with the string summary. So let's click F10 and this will be successfully deleted from the queue. Now if we go back to the Azure Storage Queue and refresh this message has gone from here. This will not appear back again. If we continue this loop, let's press F5. This is going to read the next message in the queue after a delay of 10 seconds and delete that as well. So this has come again with the next message. So if we look at the weather data, we can see this is the message with never expires. Now let's click execute and this is going to delete that message as well. Now if we come back to the queue and refresh this, both the messages are gone. Now if you keep refreshing this is not going to appear again anymore. So anytime you read a message, it's going to make the message disappear from the queue temporarily. This is because we don't want any other processes to pick up the same message. In these cases, we expect the messages to be processed only once. So in this particular case, if you look at the receive message async, this has an overload which has a timeout as well. Now by default, this is set to 30 seconds. This means that when you read a message, this will be hidden from the queue for 30 seconds. After 30 seconds, it will appear again. You can specify this to be different values. So if you specify 10 seconds, you will have to complete your application process within 10 seconds. And if you don't respond back, the message will appear back in the queue for some other application to process. To make sure the message has not appeared back, let's go back and refresh and the messages are still gone. If your application process has thrown an exception and has not called the delete message async, this message will be available for the next process to pick up again after the default visibility timeout on your receive message async. So in cases where your process can take more time, you should use a different timeout when you are receiving messages async. You also need to make sure in your handler of processing that you are not reprocessing the same message again. This will avoid any kind of conflicts that you might have in case the message is getting delivered twice. This will allow us to handle for any exceptional scenarios where you might have already processed but not reached back to the queue within the timeout period. Now that we understand how to write, read and delete messages, there is also one more method in the message which is peek. So if you look at queue client, there is a message called peek message and peek messages very similar to read. In these cases, these messages are not removed from the queue like the receive message. We are just looking at the queue to see what the messages are. Typical use case for this is the Azure Storage Explorer. So when we are refreshing this, all this is doing is a peek into the storage queue so that the message is still available for somebody else to process. It just shows the current state of the message. This is the same functionality that is used inside the Azure portal when they are listing the messages in the UI here. If they use a read, then that message won't be available for our application to pick up, which is why they use peak. So if you are building such similar UIs or dashboards for messages, you should be using the peak message. Let's now see how we can remove the connection string and the queue name dependencies in this particular application. Now, rather than hard coding this queue client, we can dependency inject this queue client into our application. So let's specify this using the constructor. So let's say queue client and specify queue client. Let's add in a backing property for this. So let's say underscore queue client. Now we can successfully remove this from here and add this inside our startup.cs. So let's remove that and start using the underscore queue client within our application. So let's say underscore queue client, which is going to be injected into our constructor. So let's save this, go to our startup.cs and register the queue client inside here. To add Azure client libraries inside the dependency injection, we can use the Microsoft.Extensions.Azure NuGet package. This allows us to register different Azure clients inside our application. So let's see how we can do that. So let's copy this NuGet package, navigate back to our application. Let's go to the Solution Explorer and say Manage NuGet Packages. Let's search for this package and install that into our application. So let's click the plus and install this inside this project. The package is successfully installed, so let's start using this. So if you go back to the documentation, you can see this uses the services.add Azure clients and uses a builder to add the client. So let's use something similar. So let's say services.add Azure clients, take in the builder and register the queue client. So let's specify builder.add client. In this case, we are going to specify the queue client. So let's specify queue client. It also has the options of queue client options, which is the options that comes along with the queue client. And let's register this client in here. This provides multiple overloads that you can use. Since currently I'm not going to use any of those, let's just ignore those parameters. So let's specify underscore to discard those parameters inside this code. And let's start a new delegate function. Inside here, we need to make sure we return a new queue client. So let's paste in the code that we just removed using the connection string inside the startup.cs. Now this is going to create a queue client. So let's return this from here. So this acts like a factory which is creating a new queue client using the connection string and the queue name, and everything is defined inside the startup.cs class. Since we removed this from the weather data service, let's also make sure we update the weather forecast controller. So in the constructor, let's add in the queue client and call this queue client. Let's add in a backing property. So let's say underscore queue client and remove this explicit creation of the queue client from here. And we can use the underscore queue client to send the message. Let's run this to see if this is working as expected. The application is running. So let's drop a new message. So let's say never expires new and click execute. Now this has successfully posted the message. So let's go to our queue. Let's refresh this. The breakpoint is hit in the code. So I think this is also read by the queue. So let's look at this message and we have this new message that we have just created inside the queue. So this summary has never expires new. So as soon as we created, our background service picked up this message because it was right in time after this delay. So let's run this, which is going to delete that message from the queue again. So as soon as we dropped, we saw our background process picking that up and deleting it again after the process has happened. Now, if you have multiple messages, some of these messages are going to show up. So let's remove the breakpoint and post a few messages from here. So let's click execute a couple of times. And if we go to the queue storage and refresh this, we can see those messages inside here. Now, as and when our background service is going to pick this up, these messages are going to disappear from this one by one. Even when we moved the queue client to the startup.cs, we still have the connection string being used here. Now, in an earlier video, I showed 5 different ways you can manage connection strings in your application. If you're using a connection string, I would move this into the app settings and also save this as part of the secrets manager, since this is a sensitive value. But let's see how we can use managed identity so we can remove the need for this connection string altogether. If you're new to managed identity, I highly recommend checking out the video linked here or in the description below. Managed identity is a feature from Azure where you don't have to explicitly manage these credentials, but Azure will manage the credentials for you in the backend. So all you need to do is specify that applications or users have the access to particular resources. Let's see how we can do that in this particular example. So let's specify where credential and specify new default Azure credential, which comes in from Azure.Identity namespace. So let's specify that. Based on where the application is running, the default Azure credential will use different ways to get the token. Now, since I'm running on my local machine, I have in Rider, in the tools, an Azure connection setup, because of which it will use my ID to get the token. Now, if you're running this inside an Azure web app, it is going to use an Azure web app managed identity to get this. I show this in the other video on how to set it up and how to get it working. So highly recommend checking that out. Now for this video, since I have all of this set up on my local, I will just show you how this is going to work. So once we specify default Azure credential, we can remove the connection string and the queue name. So let's remove both these lines and use a different overload from this queue client. We'll choose the one which has the queue URI and a token credential. So let's specify queue URI and the credential that we just created, which is the default Azure credential. So let's specify credential and let's define the queue URI up here. In this case, this is going to be a new URI and we need the full URI to our queue in this particular example. So if we go to the Azure portal and go back to the Azure Storage account and copy the URL from this queues list. So here we have the full URL. So let's copy this and use this from our application. You could move this into an application configuration, and this is not any sensitive information. I highly recommend checking the video where I show about the 5 different ways you can manage these configuration values if you're running in an Azure environment. So once we have this set up, this is going to use default Azure credential to get a token to talk to this queue client. Now before we run this application, we need to make sure we give access to this queue for my username. Since I am running this IDE under my account, I'll have to explicitly do that. So let's navigate back to the Azure portal. Let's go into the IAM access control on the left side for the storage account and let's click Add a Role Assignment. Here, we can select different roles. In this particular case, if you scroll down, you can see different roles for storage queues. So here we have the storage queue data contributor, or based on your application, you can simply give a reader or a writer role. So in this particular case, let's choose storage queue data contributor, which means I have read, write and delete access to the queue. So let's select that and search for my username. So this is against my email. So let's use my email ID to find me up and click save. Now this is going to add a new role assignment which grants me the access to read, delete and write messages into the queue. The role assignment is successful. So let's go to the role assignments, click refresh and you can see the assignment down in this particular list. If you come back to the application and run this, this should all work as expected. So let's run this application again. The application is running. So let's click execute and this has responded with a 200 success code. Let's click a couple of times this so that we have the message inside the queue. Let's navigate to the queue. Let's go to the queues section and navigate to our add weather data. Now if you refresh, you can see these messages appearing again here. So as and when the application is picking this up, this will disappear from this queue. So let's navigate back to the console and here we can see our background service is picking up this message every 10 seconds. If we put a breakpoint here, you can see this has now successfully picked up the next message. So if you look at the console logs, you can see the logging messages for each of these messages that's getting picked up. So let's resume the execution and we can see the logs coming up here. Now since we have added the library, the Azure.core logs is also coming inside our logs. If you want to mute these logs, we can simply copy the Azure.core, which is the category, go into the app settings. If you go into the app settings.json, we can set the logging levels for that library. So let's specify Azure.core and say only log warning messages. So this is going to stop this particular logs coming from here again. So if you refresh, if you clean this logs, you can see from the next time this is going to run, it's not going to show the Azure.core if I fix the space correctly. So let's save this again, which will auto reload this config, and then let's clear this again. Now you can no longer see the Azure.core logs coming here. So if we go back to the UI and refresh this, since all the messages have been picked up, let's click execute a couple more times and come back to our console, and we can see the logs are much cleaner now again. Now with managed identity in the startup.cs class, we don't have any connection strings or sensitive information managed by this application. We have completely removed the need of a connection string or handling them explicitly from our side. I hope this helps you to understand more about Azure Queues and how to use them from an ASP.NET application. When you have long-running processes or you want to decouple applications, using a storage queue like this is highly recommended. Some of the typical examples where you could use storage queues are sending an email, or doing long-running processes like these for your application, or even for communicating between different applications. These are heavily used also with microservices-based architecture. I will be covering more ways of consuming messages from a queue in following videos. So if you like this video, please make sure to hit the like button. If you have any questions or feedback, feel free to drop them below. If you want to be notified of future such videos, don't forget to hit the subscribe button. It also helps me to grow this channel. Thank you and see you soon.